this next one is one that I think is kind of fun, but when you first see it, it can be a little intimidating. They want you to find all the other zeros of this polynomial given that -2 plus 3i is a zero. So in the other instances, we're either told outright what a zero is, or we're told that there is a rational zero. Here we're given a complex zero, okay? So again, we're going to start by copying down our polynomial. So it's p of x equals x cubed plus 6x squared plus 21x plus 26. Okay. And we're told that it has a zero, okay? -2 plus 3i is a zero. Okay, which might strike you as a little strange because -2 plus 3i is a complex number, but if we look at the coefficients of this polynomial, they're all real, okay? We don't have any complex coefficients. So this takes us back to that idea that when you have a polynomial with real coefficients, the complex zeros can't just be on their own, they have to be in conjugate pairs. So if -2 plus 3i is a zero, that means that -2 minus 3i is also a zero. Okay? So from there, what we want to do really is attempt a linear factorization and see where that gets us. Okay? So we can rewrite this as p of x equals, now we'll have x. Now it's going to be minus, okay, so x plus 2 plus 3i times x plus 2 minus 3i, okay? And then we don't really know, okay? It's going to be x minus something. We'll call it k, where k is that third unknown zero. What we do know for sure is because this is a polynomial of degree 3. It has exactly 3 complex zeros. We have 2 complex zeros that are in a conjugate pair. This k has to be real, okay? Remember, all the real numbers are part of the complex numbers, but this number k cannot have an imaginary part, because if it had an imaginary part, it would need its conjugate there too if you had these real coefficients, and you can't have its conjugate there because then you'd have 4 zeros, but this is a polynomial of degree 3. Okay, so we do know a little bit about this, we just don't know exactly what number k is, but it'll be pretty easy to figure that out. The way that we do that is we want to distribute, okay? Distribute and figure out basically what the quadratic part, what the quadratic factor of this polynomial is. Okay, so we're going to distribute. When you have trinomials, you can FOIL, just like with binomials, it just takes a little bit longer. Okay, so we'll wind up with, we have x squared, okay, plus 2x minus 3ix, okay? Then we're going to do the same thing with the 2, okay? So we have plus 2x, okay, plus 4, okay, minus 6i, okay? And then we have plus 3ix, okay, plus 6i, okay, and then finally we have 3i times -3i, okay. So the way that we do this is we have 3 times -3, that's -9, okay. Then we have I times I. Remember, I times I is I squared, and I is just the square root of 1, so I squared, or square root of -1 rather, so I squared is -1. So we have -9 times -9 times -1, so this winds up being plus 9, and then we still have that x minus k. We can neaten up this stuff in the parentheses quite a bit though. Notice we have minus 3ix and plus 3ix. We have minus 6i and plus 6i. This is the reason that any complex number with an imaginary part or non-zero imaginary part has to have its conjugate in there as well, because when you multiply two conjugates together, the imaginary part sort of disappears, okay, which is exactly what you want when you have real coefficients. So what's left over is x squared, and we have these two x's here, okay, or two x's rather, so x squared plus 4x, okay, and then we have 4 and 9, so plus 13, okay, times x minus k. Still don't know what x minus k is. Here's how we figure it out. Instead of using synthetic division, okay, or synthetic substitution, we're going to use polynomial long division. Okay, so we're going to try to divide, okay, x squared plus 4x plus 13 into our original polynomial, x cubed plus 6x squared plus 21x plus 26. Okay, the reason we're doing this is because we effectively know that this polynomial is evenly divisible by this quadratic. Okay, all that remains is to see what the quotient is. Okay, so we have x cubed here as our leading term. So we'll have an x up here. We multiply the x into this, we get x cubed, okay, plus 4x squared, okay, plus 13x, okay, and then we want to subtract this whole thing. Now what comes out from there, the x cubes cancel, we get 6x squared minus 4x squared, so that's 2x squared, okay, and then we get 21 minus 13, so that is going to be 8, okay, so plus 8x, and finally plus 26. You can kind of see where this is going, plus 2, okay, so 2x squared plus 8x plus 26, subtract, we get 0. Okay, so it's evenly divisible, our remainder is 0, and the quotient is x plus 2. So p of x, okay, p of x equals x squared plus 4x plus 13, oops, times x plus 2. Okay, so our zeros, and they want you at the end to enter your zeros. Our zeros are going to be negative 2 plus 3i, okay, negative 2 minus 3i, okay, the conjugate, and negative 2. And those are your answers.